Okay, this is the second video. In this video, we're going to look at these two graphs and answer a bunch of questions about the graphs to make sure that we understand the concept of how these derivative rules work. And so we have the derivative of f of g of x. Okay, that is a composite function. That is a function who is inside of another function. And so what we do with such a function is to use a chain rule. Now we can write it in prime notation or in d notation. I think it's best in prime notation. And so in this case, actually no, they have d dx. So d dx of f of g of x means that you do the derivative of f. Let me use prime, but you plug in g, and then you multiply by the derivative of g. So if you want this evaluated at x equals 4, then we have f prime of g of 4, and we multiply that by g prime of 4. It's the chain rule. So we're going to start with this g of 4. When x is 4, g is 6. So g of 4 is equal to 6. Now, it's our job to plug that 6 into the derivative of f. Now, what we'll be looking for is the slope of the tangent line, right? That's what the derivative is. And so it's not this function value, 6 to give you 3. What it is the slope of this line. Now, how do you look at a line and know its slope? You got to look at the rise over the run. It's helpful if the line goes through corner points, because then you can get an integer value for the rise and an integer value for the run. This rise here is 2. This thing goes up 2, and then it goes over 4. The rise over run is 2 over 4. F prime of 6 is 2 over 4. That's the rise over the run, and that's 1 over 2. So f prime of 6 is a half. We take that half, we do the same thing on g, but that one has a 4 inside of it. So we go to the 4, not looking for the y value. What we're looking for is the slope. Find another corner point that it goes through. And the rise is actually a fall. You go down 1 and you go over 1. So g prime of 4 is down 1 over 1, over to the right always. And so that's a negative 1. Multiply these two results together and you have negative 1/2, or negative 0.5 as the letter B has. Okay. Now, if we didn't have a line, then it'd be hard to find the slope. You have to draw the tangent line in. But when you have a line, the line and the tangent line have exactly the same slope, so it makes it easier for you. All right, great. Example 2 here, question number 6. This time we're looking at a product. F written next to G with the parentheses, and then a prime symbol is the derivative of the product. It's like f times g's derivative. So the product rule has to take place. We have to take the derivative of f, leave g alone and multiply it, put a plus sign, leave f alone and multiply by the derivative of g. They want this at x equal 1, so we'll put a 1 in here. Well, let me put it up here. F prime of 1 times g of 1 plus f of 1 times g prime of 1. Okay, that will be what we're looking for. Let's get the easy parts first. G of 1 and f of 1. That's the actual function value. So the y value when g is 1 is a 3. the y value, when x is 1 into g, you get a 3. When x is 1 into f, you get a 4. Okay. Now those guys separately get multiplied by some slopes. So what is the rise over run at 1 on f? Find a corner point and go down and over. This is down 3 and over 1. So that's a negative 3. In G, find a corner point, find another corner point, go up 2 and over 1. And so we'll be multiplying by 2. For a final answer of negative 9 plus an 8, so we get negative 1. Letter C. Okay, so we're just executing the product rule, the quotient rule, but using it without actual formulas for the functions, using it with the graph. Next up is going to be the quotient rule. This is f divided by g. So the quotient rule is that the d dx of f of x over g of x is square the denominator, bring the denominator up to the numerator, multiply that by the numerator's derivative, put a minus sign, leave the numerator alone, multiply by the derivative of the denominator, they want this at x equals 6. So let's go ahead and get g of 6, get f of 6, get f prime of 6, and get g prime of 6, and plug them in. So f of 6 and g of 6 are easy to get. They're just the y values. So g of 6 is a 4. F of 6 is a 3. And now we need the slopes there. And so what's the rise over run? Find the corner point. And as you move from left to right, you go up 1 and over to the right 2. So that's a half for f prime at 6. For g, find a corner point. And yeah, you go down 1 and over 1. And so that's a negative 1. So we're going to take these guys into this formula where we take g of 6 and square it. We take g of 6 and put it up here, multiply it by f prime of 6. Then we take f of 6 and multiply it by g prime of 6. And this would be our derivative of f over g. And then this bar x equals 6 means you're plugging in a 6. So g of 6 is 4. F prime of 6 is a half. Minus f of 6 is 3. G prime of 6 is negative 1. That's all divided by g of 6, who's 4, and that gets squared. 2 plus 3 over 16. So we get 5 over 16, but these answers are decimals. And so I want to go with letter D. 0.3125. And so we got to go with letter D if we're rounding to 2 decimal places. Okay. All right. I think there's one more of these with the chart where we have x squared plus f of x, the derivative of that. So our function, let's not say g, our function h is x squared plus f of x. And I want the derivative of it. What's x squared's derivative? Using the power rule, you get 2x. What's f's derivative? We just use the symbol f prime of x. You want this at x equal 3. All right, I can plug a 3 into that. 2 times 3 plus f prime of 3. So I'm going to get a 6. And then I got to go find out what the derivative is at 3. Now this time, We are not at a corner point, unfortunately. The function isn't, at least. But as long as we can go along this line and find 2 corner points that it goes through, the slope between these 2 points will be the same slope that's going on at x equals 3, where we go up 1 and over 2. So f prime of 3 is 1/2. And so that's going to be 13 over 2 as an improper. As a decimal, 6.5. Okay. All right, great. So this is video 2, and we'll continue on to the next video.